Hello guys, good morning, good afternoon, good evening. This is Mahesh here, and today I'm going to talk about evolution of locking in Fiori apps. And about myself, I'm Mahesh. I'm an ABAP UFA developer working for a government organization in Ras Al Khaimah in UAE. Let's When I say about evolution of locking in Fiori apps, locking means I'm not talking about locking of some application or something. I'm just going to talk about locking of data, application data. So like two-person cannot access the same data at the same time, not reading, editing the same data at the same time. So this kind of locking I'm going to talk about, locking of data, object data. And this session is especially useful for those who are kind of new to SAP world, especially ABAP, UI5, these things. Because when I was new, I was not able to implement a lot of features like locking in my applications, which was very much required, but because I don't have much knowledge about them, so I have not implemented. So the same mistake should not be done by everyone, right? So it's better to learn about what is the impact of locking and how much easily you can implement in your applications. So first I'll talk about agenda what today I'm going to talk about. One is first is why locking and then types of locking and different types of locking. In general, we are talking about in general types of locking. How many types of locking are there and how many types of logging are currently available in our Fiori apps that also in ABAP world. I'm talking about ABAP environment. And for example, there is Etags, soft state, durable lags. So I'll talk about them in depth. Not in depth, but enough to get you started with this. Okay, now let's move to why locking. So why locking? Let's say if there are two persons who are trying to update the same data at the same time. So first person already updated the data with some XYZ value. So second person is updating with another field with the ABC value. So now what happens is the second person who is updating the data will override the data already entered by first person. Ideally, both should coexist. But because there is no locking implemented, this guy was able to update the same data and this guy was able to override this new data with old data because they both access the old data at the same time. So maybe I'll show you with some examples you might understand easily why locking is required. So with an example, very generic example I'll talk about is booking tickets. So let's say there's a favorite movie in your theater and you booked a ticket because usually we don't go there nowadays, so we try to book it in from online, right? So you are booking it from online. So same way, my friend is also booking it from his home. So we both are booking it, and I selected A1 seat. He also selected A1 seat. It allowed both of us to select it, and then I went, and then ahead, and I paid for paid the transaction and completed the transaction. And he also did the same thing, but for me, I got the ticket. For him, he didn't get the ticket. He got an error that yeah, the ticket already has been issued. Ticket is not available. So what he has to do, he has to go back again and he has to go through the whole process of selecting another seat and he has to get a ticket, right? So what happened here? If there was locking implemented initially itself, if I have selected ticket seat number A1, the my friend should have got an error message that the A1 has already been selected. So system should have told that to select A2. But this didn't happen in our case because the locking is not implemented here. Luckily, in all our websites where we are booking tickets, the locking is there, everything is there, so we don't need to worry. This is just a very general example what can go wrong. Okay, so because of not locking is not implemented, we both face some issue. Not me, my friend. And in worst case, if they don't even have locking, the checking ticket is available or it had been already booked by me at the end, right? So for both of us, the same seat will be given, same ticket will be issued. So that will be even major problem. So multiple issues might come out because there is no locking implemented. So all these things could go wrong. And especially concurrency and consistency. So when I say concurrency, multiple people can access the same application at the same time. So see here in this scenario, as locking is not implemented, if a one person was updating the data, it would have make sense. It would have made sense because there is no need for locking and there is no concurrency. Multiple people cannot access it. So then it makes sense. And also, let's say both updated the data and database got corrupted because they have not implemented any sort of logging. They both got issued the same ticket. So what happens? Consistency is missed. So these are the problems. You will miss concurrency and consistency of the database table. It's the same with the sales order. So I'm trying to update some sales order data and some other person is also updating the same sales order data. We're trying to update the same sales order at the same time, and only one of our changes will be saved. Whoever saves it at the end, right, those changes will be saved. Ideally it should have given error in the initial stages itself. So we are missing all this if you don't have locking. You must have got some idea that locking makes a lot of sense. If locking is there, a lot of things might get better. So but what are the kinds of locking that are available? They are basically, in general, optimistic and pessimistic locking are there. Okay, now let's see optimistic locking. Optimistic locking, let's say if there are two persons, this guy, person A and person B, trying to read the same sales order ABC, and now sales order ABC was updated by person A. He tries to edit it and he tries to update the data. Okay, fine. Now in the system, in the backend, in the server system, so it will check, system will check whether the data that has been updated by the user, he's trying to update the data, is the latest record or not. Because when he is reading the data, let's say he read timestamp. Let's assume he read the timestamp, and when he's trying to update the data, he's passing the same timestamp here. It will check if both the data is same. The data that he is editing here, right, is the latest record or not. Because it should not be the old record. It should be the latest record that he has read here. So it is the latest record, and he was able to save the data successfully. Let's say for this person here, person B, he also, if you see, they both read the data at the same time, but he's updating and she's updating and editing the updating and editing and updating the data after person A has updated it, after person A has saved the data to database. Now what happens? The system will go and check if the data that she is updating is the latest record or not. The sales order she is updating is the latest sales order or not. If you see, the sales order she read here is a old sales order. When these both are reading the sales order, right, this is old sales order. That sales order she is updating it. But in the database level, when this guy updated the sales order, our database also got updated with the latest sales order. So latest sales order, and this guy is working on the old sales order, this lady. So there is a mismatch and the error will come. So this is basically optimistic locking concept. So we'll move on to pessimistic locking. So in pessimistic locking, what happens is, let's say two person are reading the data at the same time. Now what happens is, person A has acquired exclusive lock. Initially itself, when he read it, before updating it, before updating the data, he got the exclusive lock. Exclusive lock means this sales order is being edited by person A, so no one can touch it. So if person B tries to edit it at that moment, she will get because she has to acquire the lock, right? When she tries to acquire the lock, she will get that the lock acquire has been failed, so she cannot update it now. She can only read the data. There are different kinds of pessimistic locking again, but I'm just talking about exclusive locking where uh, read can be accessed by anyone, but update can only be accessed by the first person who has acquired the exclusive lock. Now he can go and update the sales order, update the database table, but for her, she has failed to acquire the lock, right? So she get the error that it has been locked by another user. But this person can go ahead, edit it, and update it. So what is the benefit here? The benefit here is, initially itself, before updating the data, editing the data, this person was able to acquire the lock and he was able to complete the transaction. But this person, before updating the data itself, she got an error that it has been logged by other person. So in this case, what happened? A lot of time has been saved by this person. Maybe this person wants to update the data with some major data she wants to update, and she kind of saved the time. She waited for him to release the lock, and then she acquired the lock and she updated it. So it goes like that. But if you see in the optimistic locking here, it doesn't work like that. These both are editing the data. She also edited it. She edited entered a lot of data, but this guy was able to save it. But this person, at the time of saving, she got error. So this is optimistic locking. Optimistic locking will check at the time of save, not at the initial time of edit. So this is a major difference between pessimistic locking and optimistic locking. Let's see how the pessimistic locking has been implemented in SAP GUI and WebDriver apps, because most of our GUI and WebDriver apps are implemented with pessimistic locking using NQ locks. So this is a very common terminology. You can Google and Google for NQ locks. You will find a lot of blogs about it, and I'm not going to discuss about them. I'll just going to talk about how it works here. So let's say the same person opened the GUI or WebDriver application, and he opened the sales order app in the GUI. Now he is reading the sales order. Okay, he's reading the sales order. Then to update the data, first he has to acquire the exclusive lock, right, for edit. So he tries to acquire it. So it is successful. In case if it is logged by someone else, he will get an error that it has been logged by another person. So no issues. Let's see if he has acquired the lock successfully. We will go to the next step. He tries to change data and save data. Of course, he has to then only once he get the data, he can update it, right? And then he closes the application. So if you see here, when he opened the sales order app here, from that point till he closes the application or the session, a single session was there. So whatever the logs that he has created here, he acquired a log for sales order. Maybe he acquired log for some sales order related tables, other tables. So all the logs will be maintained here. Once he saves the data on commit work or by closing the WebDin Pro browser URL, then what happens is session will be terminated. Till that time, one single session will be maintained for this user. There all the logs will be there. This is in general how it works for SAP GUI and WebDin Pro apps. Let's see, because our main agenda is to go and check how the locking will work for Fiori apps, right? So let's go and check for our Fiori apps. So in Fiori apps, if a similar kind of locking is applied, how it will behave, let's see. So let's say the another person who was getting all errors till now, she again opened the sales order Fiori app. So now she tries to read the data. You know, right, in Fiori apps, usually in general, we follow OData service to read the data, update the data and all. So initially when she opened the Fiori app to read the sales order, obviously a OData service request will be sent. She reads the sales order and she displays the sales order. But if you see, this is all one session. What happens is once you read the sales order using the OData service, because it's a web call, right? OData service is a web call. And Fiori app resides on the browser. Fiori app will be loaded in the browser, and OData service is an intermediate layer between Fiori app and our backend SAP system. So we use OData service to communicate with the backend. But unlike in GUI apps, everything resides on the server only. It's like even WebDin Pro application also, there will be multiple round trips, a session will be maintained for it. So it's a different thing. You can check a lot about differences between Fiori apps and WebDin Pro apps. It's very interesting. But I'll just give a very brief idea about it. So the thing is, any communication happens with OData service. You will call OData service, a call will go to back and it will fetch data and it will come back. So the call will be completed. So same thing happens to happen here also. So she read the sales order. Sales order is read. She read and the session is opened. She acquired the sales order data and the session is automatically closed once the request is completed. Now she sends another OData request to acquire exclusive lock to edit, like how it is happening in Webin apps, right? Similarly, we are doing it. We sent a request to lock it. Now, what happened is, because this is a OData service request, a request went, created the lock, and automatically closed the lock, close the session. So what happened once the session is closed, we know that all the locks will be removed automatically. So it's a big issue here because there are multiple sessions here, unlike in SAP, GUI, or WebInfo applications. So now let's assume in best possible scenario, if two person are updating at the same time, sending the request to log the data at the same time, then they will get error. This is a possible scenario which will never happen because it's a very rare scenario, but it's possible one. But this is very rare scenario. In the same OData request, right? At the same time, the OData service request has to hit SAP application server, then only this will happen. But anyway, let's see what happens is this person goes and saves the data by sending another OData request. So another third session will be opened. So at that point of time, already locks and all will be removed. So let's assume that another person is updating the data at the same time, right? So they will get an error. They will not get an error. Of course, they will not get an error. So this person is trying to another person also trying to update the same solder, right? They will be overriding the data if they are trying to access the data at the same time. So the locking is not at all applied here. The exclusive locking we are talking about. Okay, so NQ locks. Now let's move to the next thing. So the issue, I already told you the issue is like it's stateless. So if you see, this is whole scenario is stateless. So why stateless? Because there was never a session that is maintained. A request was sent, it came back, so session was closed. So there was no state that is maintained. So that's why it is stateless. And no locks. Even if you open the lock, it will be closed automatically when the session is closed. Once the OData request is completed. So there are no locks maintained and data inconsistency. Of course, if two-person are trying to use the same application to save the data, so there will be inconsistency in the data. So now how can we solve this in the Fiori apps? One way to solve this is using Etags and soft state durable locks using draft. So we'll see them one by one, and first we'll see Etags. So Etags are called as entity tags. So their actual purpose initially was to do cache validation. Like let's say there is a browser that is loading some heavy resources, and uh, because every time if you open a browser, you cannot load the same data again and again, right? So we can cache some data in the Chrome in our browser, right? So we don't need to send request to the server again and again. We can cache some data. So this is the idea behind it, etag, and they were now the same idea has been used in locking mechanism. So the optimistic locking I was talking about, right? So we'll use the same methodology there. So I'll give an example here to for you guys to get a good idea. So let's say there's a client A. Client A means browser A, and client B, browser B, and server is nothing but our SAP ABAP system, and we are calling a get call. Get call means we are using a OData service to read some data. So let's say this person here is trying to read data. Initially, he read some data. Let's say sales order A he has read. So once he read the data right here, if you see there is something called ETAG here. So this ETAG is actually a unique value for that sales order. Usually unique value for the sales order which gets changed on every change is in the sales order data is timestamp. Here timestamp can be an unique data in the sales order. So what happens is every time you update that data, right, update the sales order, our timestamp gets changed. So it's only unique at that particular point of update. After the update is completed, then ETAG will be changed. So now what happens is he read the ETAG here, this ETAG. Now this guy tries to save the data by using put request, and then he has to send it in if match header. So in the browser request, right, he has to send in if match header the same ETAG that he has received when he used the get call. In the get call, our SAP system will give the ETAG. So he has to pass the ETAG in the if match header. In the system, if you see, no one has updated till now. We are the first person who are reading the sales order and we are trying to update it. So ETAG is the same in system as well. Our timestamp is same in the system as well. That's why it allowed him to update. So there was no error. But let's say here this guy has client B also has read the data at the same time when client A has read the data. So both has same ETAG here. Both has same ETAG. But meanwhile, this person already has updated the data. Now client B is updating one after client A has updated the data. Now what happened? Earlier, let's go to client A when he updated the data, right? In the system, the timestamp got changed. See, the timestamp is different here. ETAG value is different here. Now this guy, when he's updating, right? But he's sending the old ETAG here, old entity tag, old timestamp. Because when he read the data, it's old data, right? How we are differentiating that it's old data or new data by timestamp. So he's sending the old timestamp here. So in the system, obviously there is a new timestamp. So there is a mismatch. So that's why he get that error that update refused. The resource has changed on the server. So there is some error called precondition failed. So this status message will be thrown. So this is basically the concept behind Etags. So this is like optimistic locking. Like I said, optimistic locking, you have to wait till the end. This is especially useful if there are very rare changes in database data records. Multiple people who are trying to update the same data at the same time, right? If it's a very rare scenario, then you can use it. Or else if your people are changing the data same data regularly, right, this is not the right case because both persons are accessing the same data at the same time and updating a lot of data, and at the end they will get an error. So it's not an ideal scenario, right? So we cannot make other person to enter all the data, and at the end we can't tell him that there is an already data has been updated by some other person, go and create the data again. We cannot do that. So that's why it's not ideal for certain scenarios. So how to use it in OData UF app? It's very simple. So you have OData service SCW project, right? So go there, add ETAG property for the entity. So here I added last changed. So it can be anything changed time, and you can also do it manually using code-based implementation because maybe sometimes see here usually there will be changed on will be not a timestamp, it will be time, it will be date, like that. There will be no mixture of both time and date, right? Which will be the unique. We cannot completely depend on time or date. So it has to be very unique. So that can be a timestamp, but timestamp usually database tables don't have timestamp fields. So in that case, we can go for code-based implementation and also do it. And let's say if we selected here last change, right? I selected here last change, and when I do a read request, then I'll get here me tag with our timestamp data. So this is our unique entity tag. So this we will use it to update the data in the database table. Now for Fiori UFI developers, right, it is also very simple. So when they are updating the data, right, update or delete methods, they have certain parameter called etag, where if they pass the etag property, right, that timestamp that they fetched here. So this time, this thing, if they send it in etag, automatically if match header will be set. I was telling you guys right here, you need to send if match header here. This is a header. If match header you need to send. So you don't need to set header value and all manually. Just go ahead and use this UFI property etag, pass timestamp. Automatically it will send the if match request. So system will take care of it. So like I said, once you give here, right, automatically system will take care of it, provided that you have implemented get entity. If you have not implemented get entity, then you need to go with a code based implementation to proceed ahead. There are many blogs available. One of the good blog by Andy Fisher, so you can check that blog. It's very interesting and very nice. It talks about this code based implementation. So issues, like I said, it is stateless. Person has to wait till the end to know that someone already has changed. So they are losing time, and they have to. They can only check if it's already updated at the time of save. So this is really not a feasible scenario in most other cases, right? So in some other cases, it might work out. Like I said earlier, if there is less chance of updating the same records by users, then we can go with this one. Or else we need to go for something stateful. So that is the OData soft state. OData soft state is like it will create session for one single OData service, only for one single OData service. That is a problem with this. So it creates one session, like how it creates session for GUI or WebDim application, right? Similarly, it will create session, but it's not the same session. It's a different session. It's a different concept. So and this is pessimistic. Like I said, if there is a session, it will be pessimistic, right? So pessimistic and it's stateful. So using this is very simple. So you go to your OData service, you will make the change as soft state. That's it. Then you have to go and you have to define the timeout. So timeout, why you define is after some time the system will automatically terminate the session. So that is why you required timeout here. Because the session cannot proceed for a long time, right? Let's say if in browser, if someone opened it, so it cannot proceed for hours and hours if that guy went idle or he closed the laptop. So it has to be closed automatically. So we have to define timeout here. And there are some optional methods in OData service DPC class. Operation start and operation end. Operation start will be called when the OData soft state is triggered, and operation end will be called when soft state is ended. So then this method will be called. So we can clear some logs or something if you like. So it's pretty simple, right? So once you call the OData service, automatically soft state is applied. But we don't want that. Maybe in certain scenarios, maybe we want to open a soft state because this is high memory consumption, right? Because a session will be open in the backend. So we want to only open it when required. Like when you're editing a data, you want to open it. So then you go for delayed invocation. So in MPC class, extension class, you will define this soft state as delayed. So what happens is you can, when let's say from the UI5 application, when they click on edit, they will call one method, create edit lock. So in that method, you can call soft state session start. So what happens is a soft state session will be started, and you can save your logs and stuff for this. And you can also terminate it. So maybe update is successful. Maybe they call save data from the UFI application. They call save. So once the save is done, we don't need session, right? Because all logs should be removed at that point of time. So then you can call soft state session in to remove all the logs. And let's say from the UFI only, if they click on cancel button, they don't need to send again another. We don't need to create another function import or something to just close the session. So there is also a feature provided by SAP called SAP terminate header session. So if you pass this header parameter from the UFI, UFI guy can pass it, then automatically the session will be terminated. So these are some nice things. But the thing is, this OData soft state session has a different concept. It's mostly for legacy applications where they have huge amount of data that they cannot afford to load every time when they load the UF application. So what they do is they will use OData soft state and they will buffer the data and they will use the data to show every time when they open in the same session. So that is the purpose of it, but we can also use it for locking purpose as well. So that is the idea. Now the issues is we know, because if 100% are opening the UF applications, what happens? Memory will be consumed. Too much memory will be consumed. That is a problem. And also if someone by mistake closes it, then the session will be like that only. So these are some problems. And the time limit, of course. So after 30 seconds, let's say if you give 30 seconds as a time, the session timeout. So after 30 seconds ideal time, right, the logs, everything will be removed automatically. So meanwhile some other person can come and edit the same data. And one more issue is that it's only applied for one single OData service. You cannot combine sessions for multiple OData services. This is also one of the issue. So now to save to now the durable locking came to help us with the locking concept, especially in the Fiori landscape, Fiori UF applications, where these are stateless applications, right? UFA applications are basically stateless applications, but we are using OData soft state to make it little bit stateful, but it's not completely stateful. Only that OData service session part we are making it stateful. So now we can use durable locking to have the pessimistic locking properties, statefulness nature for the locking only, for Fiori apps, which is very interesting, right? So, but this Like I said, this is pessimistic plus optimistic. I will talk about it why I'm saying pessimistic plus optimistic. This is very interesting, and this is not completely. I mean, like it is reproducing stateful behavior. Not it's not stateful, but it has stateful properties. It's a stateless. Obviously, fewer applications are stateless, but it behaves like stateful. How is because how is using the ABAP programming model for Fiori. So ABAP programming model for Fiori is a new methodology architecture where you create the new Fiori applications with draft features. So this durable locking is also is only will only work with ABAP programming model for Fiori that has draft enabled. Then only it will work, or else it will not work. So that is one thing that I want to point out about durable locking. So we'll dig into durable locking a little bit. So I'll talk about general stateful behavior. Till now we have seen, let's say there is a client, let's say SAP GUI application. Let's say SAP GUI application. You are updating some data here, updating the data in a GUI application. So this backend is there, right? This will be temporary internal table. So all the data that you update, change everything, right? This will be in temporary internal table, all the updates. You have not saved yet. You are just doing some update to some table that is shown in the ALV or something. So all that will be updated to internal table, right? Obviously. But at the time of save, what we do is we take that internal table data and we will save it to database table. So this is general stateful behavior in our GUI applications. So now let's see how with draft draft. I'm not talking about durable locks. I'm talking about draft support because this is very important to understand durable locking. So how draft will work? So draft is like it. This only, like I said, this will only work for ABAP program model Fiori. Even RESTful ABAP program model has not doesn't have support for it yet. Maybe in future, in couple of months, we might get it. But currently, draft is not supported for ABAP RESTful programming model. So this is only for ABAP program model for Fiori. Now let's say this draft is there, right? So what is this draft? This draft is not internal table. This is also a database table. This is database table similar to backend database table. So they both fields will be in sync. It's like if you start digging into other program model for Fiori, you will understand what is draft table and all. They are based on the CDS views. So it's like they will create system will automatically create another system will create. We will not create this. System will automatically create a draft database table. This is also a database table. In the backend, this is actual database table. Let's say this is mara table. This will be mara underscore temp. Let's assume this is mara underscore temp. So what happens is if someone is editing material, right? All the intermediate changes earlier, what was happening? We are saving it in the internal tables here. At the end, we are saving it to database table. But what we are doing here is we are saving it in a database table itself. In a new database table, draft database table that system has automatically created. We are saving everything there, intermediate changes there. And at the end, when the activate method is called, at that time we will actually save this intermediate draft tables will be there, right? We will save the data to actual Mara table. So this is how draft works. So why we have another database table here? So what is this draft database? What is the purpose of it? So let's say you are in a browser, you are doing some changes. Whenever you do changes, you will immediately save it to draft database table asynchronously. In the background, you will save it to draft database tables. You are not saving it to actual database tables. You are saving it to draft database tables. Let's say you system crashed and then you open the application again, right? So you will have the draft data. So you open the same material, so you'll be able to see the same draft data there, same draft material there. So you can continue the changes there. So that is one of the advantage of the draft. And one more advantage is, let's say you have to go to home and you have to work. Your time is over. So what you are doing some changes, very large amount of changes. So what you do is just close your browser. You will go back to home. You will open it. As the draft table has all the data that you changed, right? So you will go back to home and you will work on that. You'll continue the changes there. So that is a very big advantage of the draft, right? But the same thing is not possible with this one because this is just internal table. If you close the browser, internal table data will be lost because it's not actual database table. Only at the time of save that it will be saved to database table. So that is the main benefit of draft. But using this draft support, right? Plus NQ logs. NQ logs are nothing but the ABAP GUI logs and all. So this draft entities and NQ logs will be nothing but the durable logs. So durable logs makes use of both draft entity data, draft data that you created, right? Whenever you do some change, right, it will create a draft data here. So this draft, sorry, this draft data and this normal ABAP NQ logs will be part of durable logs. Okay, so we will see more into durable logs. And there's also one more advantage of durable logs. So durable logs, like I said in the beginning here, durable logs are both pessimistic and optimistic. Why I'm saying both pessimistic and optimistic means because it supports both ETAG and exclusive log. Exclusive log is nothing but NQ log. So it supports both ETAG and NQ log as well. So why it supports both of them is, let's say if you're doing some changes to a draft data to uh, if you're actually editing a database table in the backend, you created a I'm sorry. So let's say we take the same Mara example. So you are editing a material. Okay, so it creates a draft entry, right? So whatever the changes you do, it will be saved in the draft table. But let's say usually this Mara table has a backend GUI transaction, right? If someone tries to change it, it should give an error because you are already editing in the Fiori application. That's why what happens is this exclusive lock is applied on active entity. Active entity is nothing but actual Mara table data. So their actual lock is applied. Now what happens is you will go, so this is fine here. Then why again we need draft entity e tag here? So let's say you opened in this browser, you did some changes, okay, because it's a draft support, your changes are saved in the draft table. Now you go back and you will open in your mobile device and you do some changes there. So you updated the draft data here. Now again you come back to laptop. I'm just talking about some impossible scenario, but there are many other scenarios. I'm just talking about very easy scenario for you guys to understand. So now this guy again came back from mobile and to laptop. In the laptop, he did not refresh the page. So he still has the old data here. Now he goes and updates that data. So what happens there? It should give some error, right? Because he's updating the old data. Ideally, he should be updating the latest data. So that's why we need etag there. So etag, what it does is it will check. You know how already etag works, right? It will check if the old data and new data timestamp is having any mismatch, and then it will give error. So good, right? So how it happens, I'll show you in SM12, right? So when I say how draft this one draft entity and NQ lock is durable lock. So this I'm talking about. It has draft ID and see this is normal table lock, SM12 lock. So they both are linked. Let's say if you are locking multiple tables, right? Usually we don't lock single table like Mara and all. We lock multiple tables along with this. So at that point of time, what happens is for one draft ID, it will lock multiple tables here. So what happens is after 15 minutes and all, if no one is working on it, no one if it's an ideal state, usually in geo also, if it is an ideal state for 15 or 50 minutes or some time, what happens, our locks will be automatically removed, right? Or if the system crashes after some time, if system automatically closes, right, then locks will be removed. So it's the same thing here. So what happens is system will automatically close all the locks after certain amount of time. In this case, draft has 15 minutes of default time. So after no one has done any changes to the application, right? If it is ideal, if someone opened the Fiori application to change the material, the draft entry is created, no one is editing it. So after 15 minutes, it automatically gets deleted. So that's why they both are linked. As well as, like I said here, someone is doing changes in the draft entity, so other person should not be able to update the active entity from the backend transaction. So that is one thing. So now let's see there are some tips like in when you are saving the database, right? Saving to database, like you are calling BAPI to save some data, you will usually get some errors that it has been already logged. So in that cases, this is a small tip. You can use this to attach the enqueue context. So what happens is whatever the function model you are calling here, to update the data, because usually BAPI sales order will have internally again another lock. So system will not know that that lock belongs to this draft ID, so it will give error. So in that case, you have to use this to avoid that error. And also I was talking about entity tag, right? E tag, how to assign e tag. So you have to use entity tag change set ID in the in our CDS view. So you can mention which field is that one. So that field will be part of e tag. So that draft entity will check if old data, new data mismatch is there. Along with that, you can also override the expiry interval. I said right 15 minutes. If no one is doing any changes to the draft data, it should automatically remove the data, because you edited something and you left it. So other person wants to edit it, but he is waiting and hours and hours. So somewhere the logs have to be removed automatically, right? So that's why 15 minutes was there to remove the logs. So now we can override it. We can change it to 1 minute or 5 minutes or 10 minutes. It's up to us. But I think minimum it will work for 1 minute. That's it. And that's it, guys. So if possible, if your system is having the latest ABAP program model for Fiori, use the ABAP program model for Fiori to do the locking. I didn't go through everything, like how to create the logs, how to do everything, because that content and all is already available as blogs, so you can check them out. They're very interesting blogs out there. I myself have written some blogs on that, so you can go and check it out. Uh, because my basic thing is to just show how locking is work, so people will be people, if they are not using it, they will start using this one. And if you're in older version, use OData soft state. But if you really don't require OData soft state because maybe the data changes will be less, then at least use ETAG. ETAG is a minimum that we have to use, or else we don't know what can happen with data. And that's it, guys. So reach out to me on Twitter, LinkedIn, or anywhere, and on my Gmail. I will be available anytime. Just ping me up. So whenever I see that message, I will get back to you guys, and we can discuss a lot about this. So if you have any doubt, you can reach out to me. But at least try to use at least try to use ETAG optimistic locking, or else data might get corrupted. So thank you, guys. Thank you very much. Bye bye.